Hey everyone, welcome to the channel. My name's Nader. In this video, we're going to go over for loops. This is a kind of companion to the while loop video, or maybe this is the one you watch first, but this is the second type of loop that we're going to look at in JavaScript. This is going to be what's called a C-style loop. There's going to be much more of a structure to it, and it's a bigger construct to the actual loop syntax. It's going to give us a bit of flexibility in how we want to actually execute the loop. So I encourage you to watch both this one and the while loop one if you haven't seen that one yet. Let's get right into it. Okay, so I've created several diagrams here, some a bit more gnarly than others. I'd like to go through these together because I think that, again, these visuals really help to understand these concepts, because as much as we want to write code, just seeing the kind of flow of things using some colors and visuals really helps. So what we have here is a for loop in JavaScript. So let me kind of go through each of these requisite parts before we actually try this out together in code in Visual Studio Code. You can see that we have a new piece of syntax. We have the for keyword instead of the while keyword like with the while loops. However, the part inside or in between these parentheses or these brackets is a part that is quite fundamentally different from a while loop. This looks quite intimidating and scary at first. However, if you give it time, it'll definitely get easier and easier and may even become one of your kind of go-to or preferred loops for most behaviors. So a for loop is really split up into these three parts that you see on the screen. We have this purple area here, which is the first part, which is the initializer. We have a conditional check, which is this blue color, and then we have in the orange over here on the right, the updater. These are all separated by semicolons in between each of them. The initializer, so this purple area, is where we can initialize variables. These are especially useful for things like counters. Normally in a while loop, what we would do is we would do this before the while loop, and then we would make sure to do something like incrementing it within the body of the loop. But with the for loop, we're able to actually put this within the construct of the loop itself. So we can declare more than one variable if we want, and I'll show you in future videos how we can also do that. For the conditional check, which is the middle component, we have the actual Boolean check for checking to see whether we should enter this iteration of the loop. So this is the part that's the exact same as the while loop. This is no different. This is just checking to see if we should enter this region right here, which is the loop body. The final region is the other new region, which is the third part here in the orange, and this is the updater area. In this case, you can see I'm doing I++, which is incrementing my I variable by 1. We can actually, very similar to the initializer, do multiple of these, chain together in a row if we have multiple variables, and update many different things, which again, I'll show in future videos. But what we're seeing here is a kind of nice place to put this and organize this all in one line, right? We have the initializer I0, we have the check, and then we have the actual updater. And this is what's going to happen after each loop iteration. So once we hit this end curly bracket, we come back to this updater and we actually get to see this code execute so that we can check to see if we enter this conditional check once again. So let's actually see this in code and actually look at a couple examples and then come back to a bit more structure. So go ahead and open Visual Studio Code. I'm just going to create a new file. I'm going to call this, let's call this for loop 1.js. I'm going to kind of create the exact same example that we just saw so we can kind of see it in action. So I'm going to say for, I'm going to create a variable. I'm going to call it I equals 0. I'm going to say while I is less than, let's say 3, I'm going to say I++. And then I'm going to console.log I, just like that. Okay. We saw that with a while loop, it was very tricky in the sense of having to kind of put the updater within the loop and always remember to put it in there. I just realized that this is a little bit small, so let me zoom in here a little bit. Maybe not too much there, I'll zoom in that much. Hopefully that's a bit more legible. But what we saw with the while loop was that we needed to have something in here, like I++, right? What you notice though with a for loop is that we don't need that, right? We have that within this construct. We kind of have a nice place to tuck this away so we don't have to really worry about whether we do the update correctly or not. It's kind of not really forced on us because it's actually technically optional, but it's a place where usually we're not going to really forget, because we usually have all these 3 parts in a row, one after the other, every single time for every type of for loop. So enough of me yapping, let me just pull up my terminal over here. And I'm gonna go node and then for loops 1, and you can see that I get 1, 2, or 0, 1, and 2, right? Because we're starting at 0, we're coming in here, then we're looping back, we're increasing I by 1, then I is gonna be 1, then we come back around, loop it again, I is gonna be 2, and finally we're gonna get to 3 for I, and then 3 is not less than 3, and then we break out of the loop. Okay, so it's a nice example of how we can kind of use this syntax so we don't actually accidentally make an infinite loop, or we don't kind of forget the condition to update, or even forget what we're using. Everything that we need for the loop, generally speaking, is tucked within this one line kind of syntactically neat package. Okay, so if I switch back here to the drawings, I want to warn you, this next one I have ready was, I was debating to even make it, but I found it quite valuable just to kind of see the flow of what's actually happened. It is quite gnarly looking right away, so if you feel intimidated by it, that's definitely the first gut reaction I would expect you to have, but we're going to go through it together step by step. So disclaimer out of the way, let's go to this one. Okay. Hopefully it wasn't too bad, but this is the crazy diagram that I came up with. So we have the same 3 parts of this loop here, right? So the for loop, I'm just breaking down kind of the order that these things are going to be running in. So in the purple, as I mentioned, we have the initializers, right? And that happens first. So what we're doing is we're creating a variable I, and we're pointing it at 0 to start. And that's what we see happening for step 1. And then we have step 2. We're going to check to see if we need to enter this loop, right? So if this is true, just like in a while loop, we're going to enter this loop body right here, right? And in this case, I is 0, and 0 is less than 10, right? So that we do enter this loop body and execute whatever code that we had in here. We can have as much code or as little code as we want. So that's the step 3 right here. Whatever code, however long this loop body is, we would execute all the code from start to finish. So once we hit this bottom curly bracket, what we do is we go back, which is step 4 here, to run any updaters. In this case, we have 1 updater. We could have multiple, and we're increasing I by 1. So we started I at 0, and now we're saying I++, so I is going to go up to 1. And after we do that, we're going to go back to the conditional of the loop, which was step 2, which is this teal area, or the blue area right here, and we're going to check to see with this new updated variable, is this still true? So in this case, 1 is less than 10, and then we're going to enter back into the loop body, and we're going to basically rerun these sections here, 2, 3, 4, and 5, repeatedly until the step 2 returns false. Okay, so this is kind of the loop part of it right here, this 2, 3, 4, and 5. We do not run the initializers more than once because they're initializers. We have to just set them one time. The only thing that updates the initializers is this step 4 here, which is the orange, which is the 3rd part of the for loop that actually updates that value. Okay, so starting values, the check, and the updating of the values. Okay. So what does this look like in the state of failing this check? I just kind of wanted to show you what that looks like just to really visualize it. Hopefully you already have this visual in the back of your mind. But once this check fails, right? So after we've gone through this loop 10 times and I is finally 10 or over, in this case it would hit exactly 10. You can think of it as doing this, right? We come to check this, we fail the check, and then we jump to after the curly bracket, to the code after the curly bracket at the end of the for loop, which is this code down here. Okay, so whether that happens right away or whether that happens much later, it doesn't really matter. We immediately, as soon as we fail that central check there in the middle, we jump down to this code after the loop. Very similar to the way that a while loop works. All right, great. So what we can do is, let's try another example here really quick. So I'll maybe create a second file. I'll call this for loops2.js. Let's just say that we want to loop a few times, and we want to change the way that we're actually doing the check to maybe check a string instead this time. Okay, so I'm going to create an initializer here. I'm going to say let str, which is the string that we're checking, equal to monkey. I'll just close this over here. And once I have that, that can be the initializer. I can also create other variables here. So let's just say I want to do comma. I'll show you how to create multiple variables. I'm going to say I equals 0 and then a semicolon. Okay. This is a bit funky syntax. This is actually a valid JavaScript line. This is saying create two let variables, one called string that's pointing at monkey and one called I that's pointing at 0. Okay. And I want to run while string is not equal to banana, for example. Okay. And I'm actually going to do I++ here. And I'm going to show you what this looks like. So let's read through this really quick, because this looks really weird, right? We now have two initializers, string pointing at monkey and I starting at 0. And we're saying enter this for loop as long as string is not equal to banana. Okay, so string is not equal to banana to start, it's equal to monkey because that's what we started at, right? So we will enter this loop. And we're saying after we hit the bottom of this loop, so after we hit line 3 in my case, increase I by 1 every single time, right? Okay, so how are we going to make this work? Because our check, which is the center area right here, the part in between the semicolons, is never really going to happen unless we force it to happen. Right? Because our updater is not actually changing string to be banana at any point in time. So we're going to be assuming that maybe somewhere inside of this loop in the body, we're changing string. So I'll show you what I mean. Let's just say if I is equal to 5. Okay, then I'm going to say string is now equal to banana, just like that. All right, and I'm going to also console.log out the loop counter, just so we can see kind of what's happening and how many loops this is actually running for. All right, so I'll pull up my terminal, clear the console a bit so we can see how this works. I'm going to run loop2.js. And you can see here that we actually are looping, well, in this case 6 times because we're starting at 0. But we do exit the loop eventually, right? And the thing that's actually exiting this loop and allowing us to stop when I is 5 is this line right here, line 3. We're saying when I is 5, change string to be banana, so that when the next loop comes around and we're checking to see if this condition is true or false, then string is now banana. So then this will end up being false, right? Okay. Hopefully that makes a bit of sense. Definitely takes some practice to use a multiple initializer like this. There are many cases where this is useful. You can actually also do multiple updates as well on this side using a comma and then an update. Let's say you had a variable called j that's also a number. You could do something like this to update multiple variables in one loop iteration. But we'll take a look at that in more detail in future videos. I'd like to go through some keywords next that are going to come in quite handy. The first one is break. Now this keyword is going to give us even more control over the loop. Currently we have kind of one way to control whether we're in the loop or not, and that's this check right here. We know that if this is false, then we're going to jump to this code out here, right? But imagine we want a case where we can control it even more fine-grained and like tell the loop, hey, like stop the loop right away, right now, stop what you're doing and just quit, right? We don't even bother going to the next loop, just quit right away. Stop what you're doing immediately, right? Like a short circuit. We saw this in the problem sets or the exercises for the while loops, but the break keyword is the keyword that we use to actually break out of a loop, right? So when we encounter this keyword, or when JavaScript encounters this keyword, and this keyword can only be used inside of a loop. We can't use this outside of a loop because that doesn't make sense. So inside of a loop, as soon as break is hit, we jump right after the curly brackets, just in the same scenario where we fail this conditional check in the center of the kind of this trifecta of the for loop, right? So just to recap that one more time, when we see a break, we immediately stop running code inside the loop and we jump to after the curly brackets. That means that this code here, up here, this will run. Once we hit the break, we jump out here. This more code area, this region down here, will not run. We won't even bother coming up to check again. We immediately jump out after the loop. Okay, so let's take a look at an example of this. I'm going to create a break.js file. We're going to say for let I equal 0, I is less than, let's go 100, and I, let's have some fun. We'll go plus equals 5 every single time. Okay, just to keep things a little bit different. I is going to go up by 5 every time, not by 1. So we're going to go 0, we're going to go 5, 10, 15, etc. Okay, so let's say that we want to console.log out the loop counter. So we want to log out 0, 5, 10. But if I is, let's say, exactly equal to 25, then I want to break. And right before I break, I want to console.log maybe like, ha, gotcha, right? For whatever reason, why not? Okay, so if I run this, so I'll clear my console here and I'll do node break.js. You can see that we get 0, 5, 10, 15, 20, 25, right? And then when I is exactly 25, so this is 25 here, and then we do the I 25, it succeeds. This conditional check, we log this out, and then we get a break, and then we immediately jump out of the loop, and we don't even bother coming in to check again. I'll prove this to you by doing a console.log. I'll show you a different way to kind of write these console logs just for fun. This is loop, and then I'll just put a comma, and then I'll put I. Okay, we can do string interpolation, which we saw in the while loop exercises. This is just a way to also do string concatenation of sorts, where we're putting these two together separated by a space. We can put as many commas as we want in a console log. We'll cover console log in more detail when we get to functions. So if I run this, we'll see something interesting. We'll see that we start at 0. We see this is loop 0. Then we see 5, this is loop 5. Then we see 10, this is loop 10, 15, loop 15, 20, loop 20. But when we get to the 25 case, we see 25 printed out, which is this line right here, line 2, printing out just a number. I is 25. We see, ha, gotcha, right? But then we hit break, which means that we jump to line 11. There's nothing on line 11 right now, but that's where the code would go to. We do not execute line 9 in the case of 25. Okay, you can see that we don't get this as loop 25 because we just jump straight after the loop body once we hit a break immediately. The nice thing about break as well is we can have multiple breaks, right? We can say if I is equal to 15, then maybe we just break directly or something, right? And just to show you how this will work, this will stop just immediately at 15, right? So we can kind of have a bit more control over when we break and the control flow of the loop. Okay, so the last thing I want to show is another control construct keyword, and that's the continue keyword. We saw this keyword when we looked at the problem sets for the while loop, but let's go into a little bit more detail in this just so we can kind of see it as another example. The continue keyword is very similar to the break keyword, but it allows us to not really break out of the loop, but break to the next iteration of the loop. All right, so what that means is that when we see the continue keyword, and this again only works inside of a loop, whether it's a while loop or a for loop, whenever JavaScript sees continue, it's going to stop. It's going to stop executing that body, and it's going to jump right back to the updater. Okay, and in the case of a while loop, right back to the conditional check. Okay, it's not going to jump outside, like in the case of break, where we jump outside here. It's going to jump to the updater in this case, right? So we're immediately going to go and change I this time, right? We are not going to run this code below the continue keyword. If we see continue, whatever code below that continue is not going to run. Okay, it's going to immediately jump to the updater. Okay, so let's see an example of this, or kind of quote-unquote practical example of this. There's many reasons why we would do this in practice, which we'll get into as we get more advanced in our coding, but for now, I'll just show you a quick example to kind of whet your appetite. I'll do continue.js as a file, and I'll do for loop, and I'll say let's just do I equals 0, I is less than, let's do 100, I plus plus for now. And you know what, let's just do I plus equals 10 actually, just so that we can switch things up, because why not? So let's say that we want to make it so if like we're logging out the number every single time to start. So let's say we're logging that out. Oops. We're logging out the number. So this will be 0, and then it'll be 10, 20, 30, etc. However, let's say that if we are at 20, then we want to like double the numbers that we're adding, right? So let's look at what that looks like. So we'll say if I is equal to 20, then I want to I plus equals, let's just say 20, right? This is going to be compounded with this updater. So this is actually going to add 20, and then the updater is going to run if we do continue right after this. And then we're going to run 10 plus 10, right? So when I is 20, we're going to come into this conditional. We're going to increase I by 20. So I is going to be 40. Then we're going to hit continue, which is going to jump us right back to the first line here. We're going to increase I by 10. I is going to be 50 now. And then we're going to kind of continue with the next iteration of the loop and come back in here and run 50, and I is not going to be 20 anymore. So that will not actually run. So if I do a console.log and I say the same thing again, a loop number, and then let's just say I, and then let's say if I is equal to 60, let's do a break. Okay, bit of code here, but let's see how this actually works. Let me pull up my terminal. I'm going to run node, and I'll run continue, and let's kind of analyze this code because it's pretty interesting. So we start at 0. We're going to print loop 0, and we're not going to enter this conditional where we saw loop 0. We're not going to enter this conditional because I is 0. Then we're going to come up and we're going to run this updater. So I is now going to be 10. We're going to log out 10. 10 is not 20. We're going to log out loop 10. 10 is also not 60. So we're going to come back up here and we're going to increase I to 20. Right? So now we're here. We're going to log out 20. I is 20 now, right? And so what we're going to do is we're going to add 20 to 20, so 40. And we're going to do continue, which means we're not going to run any of this code down here. We're just going to immediately add 20 and then add 10 right here for the next iteration right away. So we actually are adding 20 and then adding 10, which is adding 30. So we're going to end up with 50, which is why we see 50 here. Okay, this 50. And then we come back in here, 50 is not equal to 20. We see loop number 50, and this doesn't enter because it's not 60. We add 10, we get 60, which is this 60. 60 is not 20. We get loop number 60, which is right here. Then we finally hit I is equal to 60 because 60 is equal to 60, and then we break out of the loop and we jump out here. Okay, so definitely many ways to control what's called the control flow of these for loops. You can create surprisingly complex behavior even with just these simple constructs of loops and conditionals, and manipulating the way that you jump in and out of these loops. Okay, so I hope that that was useful. What we're going to do is get even more practice with this, just like we did with while loops in the next video, where we're going to go through a bunch of exercises or problem sets on for loops. And that's going to set us up really, really nicely for the next topic in this series, which is going to be functions in JavaScript. It's one of my favorite topics. I have a whole bunch of beautiful pictures, as usual, ready to explain that in depth as best as I can. I can't wait to get to those videos. If you enjoyed this video and found it valuable, please like the video and subscribe to the channel. As well, I'd love to hear what you thought of the video in the comments, as well as anything else that might have come up that you might be confused about throughout either of these videos on loops. But that said, I'll see you in the problem set video for loops, and then in the functions video right after that. See you later.